Dear friends, this is an IIT problem. IIT JEE 2013, this question was asked. First I will read the question. After that we will solve. Parallel plate capacitor of capacitance C is connected to a battery is charged to the potential V. This is the first step. First, there is a battery, there is a capacitor. It's a capacitor. Let it be positive. This is negative. These two plates are connected to a battery, potential difference V. Then here the potential difference across this capacitor is V. Capacitor is V. Then the charge stored inside the capacitor is Q1. Q1, you know, that is Q is equal to what? CV. This is a formula, you know. That is Q1 is equal to what? That is C. Here the capacitance is C. That is a capacitance C. That is C. Potential V. Let it be. This is the first thing. Parallel plate capacitor of capacitance C is connected to a battery and is charged to the potential V. Next, another capacitor of capacitance 2C is charged to the potential 2V. So next situations. There is another capacitor. The same manner, this is positive charge means this is negative charge. Both plates are equally charged. This is connected to the battery of potential difference 2V. Here the charge is 2C. Here the charge stored, capacitance is 2C. The charge stored here is Q2. This is the thing here. Another capacitor of capacitance 2C is charged to the potential 2V. Is charged to the potential 2V. The same manner, that is Q2 is equal to C2 V2. This can be written as, instead of C2 2C, V2 2V, then this can be written as 4CV. 4CV. Next point here. The charging battery is now removed. That is a disconnected. Charging battery is disconnected. That is disconnected. And the capacitors are connected in parallel. Capacitors are connected in parallel to each other. But condition is also given. Positive terminal of one capacitor is connected to the negative terminal of the other capacitor. Now I will draw the battery is removed. This is the first capacitor C of capacitance C. This is another capacitor of capacitance 2C. These two are connected parallelly. The condition here is positive plate is connected to the negative plate. Then this is negative, this is positive. The battery is disconnected. battery is disconnected. Battery is disconnected. Here the charge is Q1. Here the charge is Q1. Here the charge is Q2. Now we find the net charge. Net charge after connecting these things. Net charge is equal to what? That is Q2 minus Q1. Q2 is here what? This is a negatively charged, it is connected here. Then Q2 is what? 4CV minus CV, that is equal to what? 3CV is the total charge. Total charge of a capacitor. The same manner, these two are connected parallelly. If the capacitors are connected in parallel, CP can be written as what? C1 plus C2. C1 is what? C. C2 is equal to what? 2C. That is what? 3C. 3C. Capacitance. Total capacitance, we found it. Then potential, we found it. Potential across this section. V is equal to what? Q by C. Q by C. Q is what? Total charge. Total charge is what? 3C V. Capacitance 3C. Then voltage is V. Voltage is V. Then what they asked here? What they asked here? The final energy. Final energy they asked. Energy stored in the system. Energy stored in the system. In the combinations. Energy stored in a combinations. That is what? Energy of the combination. U is equal to what? 1 by 2 C parallel B square. That is 1 by 2 C parallel, 3C. 3C. V, total potential V, that is what? That is V square. This can be written as the energy stored here is 3 by 2 CV square is the energy stored in the system. If we connected these two capacitors in parallel with each other, the energy stored is, we found it here. Then which option is correct? The second option, 3 by 2 CV square is the correct options. We found it correctly. And this question was asked already 2013. It's a very simple problem, but only thing is we must understand the basic concepts. The parallel plate capacitors connected. Again revising this one. Parallel plate capacitor of capacitance C connected to the battery of voltage V. For that I explained this one. Then next statement. Capacitors are connected to the capacitor of capacitance 2C is connected to the potential 2V. That also I explained here. Explain this diagram. Now the battery is connected and these two capacitors are connected parallelly. Then you find the total capacitance. Since if they are connected in parallel, just add it. You know the formula, basic formula. Then potential can be written like this. Then finally, this is a basic formula for energy stored in a capacitor. That is U is equal to 1 by CV square. Here these two capacitors are there. Then CP V square. Instead of CP, 3V. V, there is no change, V only. Then 3 by 2 CV square. Then here the option, second option is correct. It's a very interesting, the second option is correct. Okay, this is a very interesting problem. If you want more problems, just you subscribe this particular channel, you can get more problems. Good. Thank you.